Beneath the surface in many of the Earth's limestone regions are large passages and caves. These are formed as limestone dissolves in slightly acidic water. As groundwater seeps downward, tiny fractures gradually enlarge into open passages. When streams and rivers are swallowed by caves, erosion continues more rapidly. Underground rivers scour out huge waterfall shafts and dissolve great tunnels. Subsequently, chambers are modified by rock fall from unsupported ceilings, and seepage water creates deposit of sparkling calcite. While young, active caves have noisy streams and cascades. Old, abandoned caves are silent wonderlands decorated with stalagmites and stalactites. Limestone is rock mostly composed of calcium carbonate, which dissolves in naturally acidic water. Rainwater absorbs carbon dioxide from the air and from microscopic soil organisms to become weak carbonic acid. As it seeps downward, it can dissolve large amounts of limestone. If that water then drips out into a cave, it loses carbon dioxide into the air and deposits excess calcite, calcium carbonate, as stalactites and stalagmites in order to maintain its chemical equilibrium. Sand, mud, calcite, gypsum, and guano are all common cave deposits, but the most widespread and beautiful are those made of calcite. Groundwater saturated with calcium carbonate deposits calcite in the form of stalactites where water drips from a cave roof. Stalagmites form where the water hits the cave floor. Banks of solid calcite on the walls and floors of caves are called flowstones. A rimstone pool forms on the surface of a flowstone deposit where water collects behind a wall of calcite. More calcite may be deposited as water flows over and down the wall. Most cave calcite contains traces of uranium. The radioactive decay of its atoms can be used to determine the age of deposition, and thus to date the cave. Karst is defined as a limestone landscape with underground drainage. It is distinguished by extensive patches of bare rock, because the weathering of limestone produces little or no soil. Rock outcrops exposed to rainfall are fretted by grooves called cairn, formed as weakly acidic rainwater runs across them. They start as narrow fissures on joints or meandering grooves, and evolve into deep gullies between pinnacles of remnant limestone. Sinkholes or dolines formed by collapses in the surface can merge to form large sunken regions, equivalent to valleys in other landscapes. As the sinkholes expand, the residual hills between them become cones, or can be undercut to form towers. The weathering of karst landforms relies on abundant rainfall and lush vegetation, to provide carbon dioxide through its decay, so the most mature karst and the largest caves form in wet, tropical areas. When streams pass underground, two main types of cave passage are formed: canyons and tubes. Underground streams and waterfalls above the water table cut deep, twisting canyon passages, by removal of limestone in solution and sediment abrasion of their floors. Below the water table, caves are full of slowly moving water, which dissolves limestone walls, floors, and ceilings equally, creating tubular tunnels. Many caves descend steeply to the water table and then continue sideways, as flooded passages, until they intersect the surface, where the emerging water forms a spring, also known as a resurgence. Left high and dry in the mountains of the Chihuahua Desert, Carlsbad Cavern has no underground river and almost no dripping water, but is a gigantic relic of long-finished karst solutional processes. It was formed in Permian limestones that were invaded by fluids rising from the hydrocarbon reservoirs in the Delaware Basin, just to the east. These fluids were rich in corrosive sulfuric acid that dissolved the limestone, removing it in solution on an unusually large scale. The Big Room, which was formed about 4 million years ago, displays evidence of this very unusual origin. Although rarely noticed by visitors, there are thick banks of chalky white gypsum left by the chemical reaction between the sulfuric acid and the limestone. Only later was Carlsbad Cavern invaded by percolating rainwater, which both continued the excavation by solution, and also deposited the massive calcite stalactites and stalagmites. Just inside its gaping entrance, the spacious Bat Cave once held thick deposits of bat guano, most of which was mined out in the 1800s to use as fertilizer. It was the miners who first explored the extensive lower passages, which contain many classic cave features. The descending main corridor is floored by huge limestone blocks, called breakdown, that have fallen from the faulted roof, totally changing its shape from the original solutional cave. Lower down in Carlsbad Cavern, the boneyard is a complex of small, unmodified chambers and tunnels that show how the limestone was dissolved in random shapes when the cave was full of water. Beyond this, the famous Big Room is not so much a great chamber as a giant, twisting passage that is over 400 feet, 120 meters, wide in places. Most of Carlsbad Cavern is decorated with a profusion of calcite deposits, and the Big Room contains some very large stalagmites within its high, open space. The big room is the end of the cave section open to the public, but large tunnels descend beneath it, ending at the Lake of the Clouds, named after the huge bulbous stalactites that hang over a deep pool where the cave meets the present-day water table. Isolated in a narrow outcrop of Precambrian limestones in the highlands near Oudtshoorn, the Kango caves are remarkable for their wealth of calcite deposits. They are a remnant of a major channel below the water table that was drained when nearby surface valleys were cut to lower levels. Subsequently, calcite deposition has occurred on a massive scale, leaving a spectacular array of flowstone and large stalagmites. Bushmen left paintings on the walls of the entrance chamber thousands of years ago, but the entrance was lost and rediscovered by local farmers only in 1780. By far the longest cave system known in the world, Mammoth Cave has a huge network of passages on many levels. The nearly horizontal Carboniferous limestone in which it occurs carries water from sinkholes on the Pennyroyal Plateau to springs along the Green River. There are many cave passages, each with a long, meandering canyon that passes into an elliptical tube beneath the water table. Downcutting of the Green River has caused the water table to fall in successive stages, leaving many large, dry, abandoned tubes. The highest level of caves contains sediments that are 2.3 to 3.5 million years old. These survive beneath the protective sandstone ridges of the Chester Upland. Most of the youngest caves drain through the ridges, where they connect with some of the older caves, while a few pass beneath the intervening Hawkins and Doyle valleys. Except where shafts drop down through the limestone beds, most follow the same bedding planes within the rock sequence. Consequently, there are numerous chance passage intersections, which have linked the caves into the one extraordinarily long system. This tiny remnant of an ancient cave passage was long ago left high and dry on a limestone hillside. The passage was later truncated as erosion wore away the hillside, leaving an open entrance in the side of the Vézère Valley. Lascaux was found by people of the Solutrean and Magdalenian cultures in the Old Stone Age, or Late Paleolithic, about 17,000 years ago. They walked into the open cave and into its dark zone, where they painted on the upper walls and arched ceilings of the first 5 small chambers, using natural pigments of ochre, iron oxide, and charcoal. They produced beautiful figures of horses, aurochs, bulls, and stags, and even created narrative strips of hunting scenes. The cave was rediscovered in 1940, when local boys pursued their dog down a small hole in the rocks and soil that masked the entrance. Its wealth of Paleolithic art is regarded as the finest in the world.